Hey everyone, I wanted to make a short video here to help you out with the end of competition assignment 3. As a reminder, at the end of that competition assignment, you're going to submit your predictions to Kaggle for scoring. And that will be the focus of this video. So I'm not going to show you any advanced model building techniques. We're actually going to build a really poorly performing model, and that's by design. We're also not going to do any of the explanation and discussion that you're going to be doing in that competition assignment 3. So just keep that in mind. The purpose of this video and this notebook is solely to help you with, once you have a model, how do you use it to make predictions? How do you get those predictions out of Google Colaboratory and into Kaggle for scoring? So as you can see, I've uploaded the data file. So this is the file that you've been working with for the car sales data up until this point. So it's the file that you've done your exploratory analysis with. I've also uploaded the comp.csv file. So this is a file that we haven't used so far. This is the file that Kaggle wants. Yeah, sure, I can open this. Please, no, go away, please. You're sick, right? Sorry, everybody. Here you go. So like I was saying, this competition CSV file is a file that we haven't used so far. This is the file that Kaggle is expecting us to produce predictions for. And I'll show you actually what each of these files looks like, just to remind you. So if we look at the header of data.csv, we can see that we have access to lots of columns giving us information or attributes about cars. And in particular, we have the price of that car. So this is the selling price. This is ultimately what we want to predict for each car in our data set. If we look at the header of the evaluation file or the competition file, we see that we have the majority of the columns are present here, but the price column is missing in the evaluation data frame. Kaggle does have access to the true prices for the cars in this data set. Our goal is to try to reproduce that column for these cars as accurately as possible. And Kaggle will keep track and tell us how well we did. All right. So if you didn't notice before, I've imported pandas. Pandas, again, allows us to deal with tabular data. I've imported the train test split functionality from scikit-learn's model selection submodule. We've used that a bunch, and I've imported the linear regression model constructor from scikit-learn's linear model submodule. What we'll do now is I'm just going to quickly split the data. I'm going to split it just into training and safe sets because at this point in our course, we're about to be exposed to a technique called cross-validation, which is going to allow us to kind of bypass the train test safe approach and actually do a much better job with assessing our model quality. So again, I'm just going to split into train and safe. I'm going to split my data. The training set, so let's say I want maybe 80% of my observations in the training set, and I do want to be able to reproduce this this notebook. So I'm going to set a random state, and I'm going to set it to 570. Again, 570, there's nothing special about that. I chose it because it's the number of our class. And then we can look at the header of the training data. And so we can see that the indices have been shuffled up, but we still have access to all of the columns that we had before. And if we compare the shape of the original data to the shape of the training data, we'll see that they have the same number of columns, but the training data only contains about 51,000 cars, where the original data file contained almost 65,000 cars. All right, up to this point, again, like I said, I'm going to build a really poorly performing model. I'm going to ignore most of the columns here. You shouldn't. So you should be using lots of the information in this data set. You've through your exploratory data analysis and competition assignment 2, you've identified the variables or the attributes that are most strongly associated with the price variable. So you'll want to use all of those, and you may perhaps want to do some feature engineering to generate new features that can help you predict with greater accuracy. I'm going to do, like I said, none of that here. I'm just going to, let's say I want to build a model, and my model is actually only going to use mileage. That will be the sole predictor that my model is going to use. So I'm going to set XTrain to be a data frame containing all of the records in the training data, but only containing the mileage column. So again, I'm ignoring all of the other available predictors. You should not do that. That's a bad choice. And the thing that I want to predict here is price. You'll notice maybe that I use double brackets on XTrain and only single brackets on price. This is because scikit-learn expects to get a data frame of predictor values, or a data frame of features, if you want to describe it that way. Using double brackets here ensures that I get a data frame back. When I use single brackets, I get an array back. So this is just a one-dimensional piece of data versus the data frame is 2 dimensions. So that's the difference there. Now I'm going to build a linear regression model. I'm going to create an object called linreg, and in it I'm going to create an instance of the linear regression model constructor. Then I'm going to fit my model. So linreg.fit. So I'm going to fit this data, or I'm going to fit this model on XTrain and YTrain. Once I have that model fit, I'll be able to use it to make predictions. So at this point, maybe this is unnecessary for you to do, but let's print out the model's intercept. I can grab that with linreg.intercept. If you've watched the model fitting frameworks video, you've heard there that anytime we have an attribute with an underscore at the end of it, like .intercept underscore coming out of a fitted model, this is indicating that that attribute was obtained through the fitting process. So this intercept was obtained through fitting. We can also print out the coefficient on mileage. That'll be in linreg.coef, short for coefficient. We see that we've built a model. We have an intercept for that model, and we have a coefficient on mileage. That coefficient is negative. That's no surprise. That indicates as mileage increases, the value of the car or the selling price of the car is going to go down. Essentially, higher mileage means the engine has less life or less expected life left. Okay, now what we want to do, or what you would do at this point, is you would assess that model. You would assess it by looking at the test set, or here we didn't create a test set again because of the type of video we're building. But you would assess your model, you would go back and try to improve it. But as a reminder, in this video, we're just trying to show you how to build a model, which we've done, then use that model to make predictions on the evaluation data, and then extract those predictions and upload them to Kaggle for scoring. So we're almost finished here, actually. One thing I want to point out is that when we go to make predictions from a model on new data, the new data that we feed to the model has to look exactly like the data that the model was fit on. Really what we mean by that is it has to have exactly the same columns. So because we fit a model that was allowed to look at just the mileage column, we're going to need to build the same thing and do the same thing for the evaluation data. So we're going to need to get rid of all these extra columns. Eval for model, let's say, is going to be equal to the eval data. And we're going to pull the mileage column for that. And now if we look at eval for model.head, we'll see that we have just that one column available to us. Now we can set a new object called predicted price. We're going to use our model, linreg, to make predictions. And we're going to make predictions on the eval for model data. And if we look at the predicted prices we built, we can see that we get a list of prices that we've predicted cars to sell for. What we really want now is we'd really like something that looks like this sample CSV file. So sample CSV has an ID column and it has a price column. The price column is these predicted prices. So we've gotten that. We now just need to construct this data frame. So what I'm going to do is I'm going to build a submission data frame. Let's call it submission DF. It's going to be a pandas data frame. And the easiest way that we've seen to construct a data frame is by using a dictionary as a medium for this. So we need, again, an ID column. Kaggle is going to expect these column names to be exactly the same as we're seeing in the submission file, the sample file. So then ID, we're going to get by going to eval and looking at the ID column in the eval data. So what that's going to do is it's just going to pull this column here, this leftmost column. That's going to be part of our submission file. You can see that the IDs actually match, which is great. And once we have an ID column, we're going to stack next to that the predicted prices. So now price is the name of that second column. And in here, we're going to put our model's predictions. So predicted price. Once we build this, we'll be able to see the data frame. We have an ID column, we have a price column. This looks pretty close to what we were seeing in the sample submission file. The only thing that we have that file didn't have was these indices, and we're going to drop them. So what we're going to do now is we're going to move this submission data frame into a CSV file. So we're going to do submission df.to CSV. Let's call it submission CSV. And we're going to set index equal to false. So what this is going to do is it's going to prevent that index column from being saved out into our CSV file. We'll be left with then just two columns, ID and price. Perfect. So now submission DF is stored as the submission CSV file. If we come over here and click to refresh what we're seeing in files, we'll see submission CSV is now there. So what we can do is use these three dots and download. So we've downloaded the file now. You can open it to check and make sure that it contains what you expect it would contain. So it has an ID column, it has a price column. All of this is perfect. Now we can go to Kaggle and make our predictions. So I'm going to submit predictions here. I'm going to click this upload button. So I'm logged in and I'm in our QSO 570 car price challenge Kaggle in-class competition or community competition. You have 5 submissions per day available to you, so you can really try to build some great models. I'm going to click the upload button. Inside of my downloads, I have this submission CSV file. I'm just going to click OK. That's uploaded. I can include a description if I want. This is going to be helpful towards the end of the semester when you're hopefully trying to win this competition. This model used mileage only to predict price, so that seems like a good tag for the model. This allows me to remember what I did and now make submission. We've made a submission. Kaggle has checked to ensure that our predictions were as expected, so that's going to check to make sure we have an ID column and a price column. And now we can check out our position on the leaderboard. I'm not sure if I'll show up here because I'm the host of the competition. Jump to my position on the leaderboard. And so I don't show up here, you will. So we can see here that I'm doing a little bit better than Kirti was. Kirti submitted this very early on in the term. So she was helping me troubleshoot the Kaggle competition site. I think you all will be able to do quite a bit better here. So this, again, is a model just using mileage to predict selling price. You'll do better than that if you include some of the other predictors available to you. But again, this has just been a video to discuss with you how to build a model, actually a poorly performing model. And then how to extract predictions for that model. So how to take the evaluation data that Kaggle wants predictions for, format it so that it's in an appropriate format for your model. Again, appropriate format means it contains the same columns as your model was fit on. So we included only the mileage column here. We made those predictions. We looked at them, we formatted them into a data frame that contained an ID column and a price column. And then we moved them to a CSV file. We hit the refresh icon. That submission CSV file showed up here in our file directory on Colab. Then we downloaded it. We simply went to Kaggle, submitted our predictions with the upload button. So let me know if you have any trouble doing this. My hope, again, is that you'll build models that perform hopefully quite a bit better than mine. All right, that's all for now. Thanks, everyone. Take care.